All right, this video I'm going to talk about graphing exponential functions. So we're going to use the table below, and we're going to graph the following function, f of x equals 4 times 2 raised to the power of x. So what I'm going to do is I'm going to use my graphing calculator a lot to kind of get through all of these things. So the first thing I'm going to do is let's actually graph this. So whenever you see f of x equals 4 times 2 raised to the power of x, that f of x is the same as just like y equals 4 times 2 raised to the power of x. So let's go to our calculator and actually graph this. So what you're going to need to do to graph this is at the top left, you're going to have a button that says y equals. You're going to hit that. What we would like to do is we would like to type our equation in here. We're going to tell our calculator to graph it, but first we need to tell it what equation. So I'm going to start with this top one, 4 parentheses 2 parentheses, and then raise it to the power of x. If you don't know where x is, that's the xt. Looks like a circle there, and that will give you x. So I have everything plugged in. When you're ready to tell your calculator you want to graph it, there's this button on the top right that says graph. So if you hit that, it might take a few seconds, but there is our graph. Wow, great, grand, wonderful. So we would like to take this and write down all the information about it and then transfer it on our paper. So what I like to do is fill in all these table of values. Now fortunately, your graphing calculator already does that for you. So if you look really closely at your graphing calculator, at the graph button, right above it in blue lettering it says table. So that's going to have our table of values. And if you want to get to that table, notice how it's written in blue. That means we have to hit the blue or the second button first. So I'm going to hit second, graph, and there is my table of values. Wow. So what I'm going to do is I'm going to copy these down onto my table. So if you want to look up, when x is -3, mine's already kind of set, but you might need to use your arrows to go up and down to find -3. So when x is -3, y is supposed to be 0.5. So I'm going to write that down. And I'm going to copy down the entire table. So when x is -2, y is 1. When x is -1, y is 2. So on and so forth. So I get 4, 8, 16, and then 32. All right, so I have this nice graph. I have the table. I would really like to take this information and transfer it to my graph paper here and try and make it as accurate graph as possible. So every little row here represents a point. So I have the point -3, 0.5, -2, 1, -1, 2, 0, 4. They're coordinates. So I'm going to try and fit as many of these on here as possible. The ones that fall off the graph, I'm obviously not going to graph. Whenever you get these decimals there, you're just going to have to do your best estimate. It doesn't have to be super precise. So my first point, -3.5. So I'm going to go from x to -3 and 0.5 there. Then I have the point -2, 1. So we go left 2, up 1. -1, 2, so left 1, up 2. 0, 4, so don't go anywhere, and then go up 1, 2, 3, 4. And then I need 1, 8, 1, 1, 2, 3, 4, 5, 6, 7, 8. My next point, 216 off the graph, 332 off the graph. So I have my graph here. I have points. It's going along this line, the x-axis here, and then kind of takes off there. So I want to do the same thing on my graph to try and make it look the same. So here we go in red. So I'm along the x-axis, follow along these points as we go up, and then put an arrow at the top. And that is my graph, and I know I've done a good job whenever the graph on my paper looks almost exactly the same as the graph on my calculator. Two more questions that need answering, though, is I would like to know where the y-intercept is and what our multiplier is. So hopefully at this point, when we talk about y-intercept, we talk about where does my graph go through the y-axis. Well, that's happening at this point right here, which happens to be at 0, 4. And what you're going to find is it always happens when x is 0. So my y-intercept is at 0, 4. The other thing I need to think about is, if you watch my exponential functions, the basic video, is we need to figure out what's our multiplier here. So how is my y value changing from 0.5 to 1, 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32. I need to think about what is being multiplied every single time. And if you look close enough and kind of figure out the pattern, you're going to see our multiplier is 2. Now, before I'm done with this, there is a little bit of a shortcut and things to kind of notice here, and we talked about this in class. This 4 and 2 also show up at one other point. So you see it more when we do a whole bunch of these problems, and I'm just doing one example. But this 4 and 2 show up, if you notice, in the original equation, the 4 and the 2. So in general, our equations that we're graphing for exponential functions, we start with y equals a times b raised to the x. And kind of the shortcut and the secret here is the a, or the first number, in this case was 4, was our y-intercept. And that is always going to happen. The first number there is our y-intercept. And that leaves our b, or what was inside the parentheses, which here in this case was 2, that is always going to be our multiplier. So that is kind of something else that is kind of hidden in these graphing exponential functions, but that is a basic graphing exponential functions problem.